interesting questions in trigonometry is the proof question, where you are supposed to prove that the left hand side is equal to something given on the right hand side. Now what you need to do is to develop a strategy. Now my strategy is that I always say for me to get to the proof, I need to earn as many marks as possible. So the first thing is I must look at both sides. Now if I look at both sides and I check to see what is making them not uniform. In other words, what is not making them uniform. So basically, usually when you are looking at both sides, you will see that there are certain things that make the sides not look uniform. For instance, one side has two fractions and the other side is 1. Now if one side has got two fractions and the other side has got one fraction, it means that the one with two fractions is most probably the one that you want to work with. So you would want to first of all show your skills of combining fractions. So if you are going to combine your fractions, you're going to have your fraction right there. You're going to have your fraction right there. So you're going to have a over b plus or minus c over d. And in grade 5 we learned how to combine our fractions. We learned that if you are going to combine the fraction, you have to multiply this denominator. We don't use lowest common multiple, and we use LCM. We don't use LCM. You just multiply the denominators, and this denominator will come and multiply there. It's AD plus this denominator will come that side is CB, and that's how you combine fractions to make 1. So normally with this method you will always get your 1 mark for combining the fraction. So I have looked out. On one side I found that there were fractions. Now let's look at uniformity. Another one which you can look out for is the tan. If you can look out for tan theta usually will exist on one side and the other side won't have tan theta. It won't have any tan. So all you have to do is to change the tan to sine theta over cos theta. That way you are now applying this identity, and that will help you to get at least 1 mark. So by looking at both sides, you are going to get that type of thing. Then the next thing we are going to say, okay, fine, can I apply any identities? That is another bonus mark which you can get for free. You've got the first identity, you've got the usually the identities that can be applied. These ones, the sine squared theta will change to 1 minus cos theta, etc., etc. So whenever you are looking at your proofs, you are looking also at whether you are using the identity. So when you apply an identity, you also get your 1 mark. So you can't really get a 0 for a proof as long as you are somebody who concentrates on what they are doing and you're not in a rush. Now the next thing you are going to try and look out for when you are doing a proof is you're going to look out for factorization, difference of two squares. This one is quite nice. When factorization, difference of two squares. So this one is very famous, and I'm going to show you how it's normally applied, and it's quite easy. And usually with difference of two squares, I normally apply it when I see something like sine theta minus cos theta, or sine cos theta plus sine theta. This cos theta plus sine theta. Usually a difference of two squares would have been applied there, and then you need to look out, and also 1 plus sine theta. These are things that you look out for when we are talking about a difference of two squares. So in case you are wondering, you want to be looking out for a difference of two squares. We'll do some examples so that you can see as we are working out questions. And then the next thing you want to look out for in terms of this question here, you also want to look out for the double angle identities. So even though we are applying identities, there are some identities which are very notorious, like this one. If I see sine theta cos theta, this is a double angle. Even though there is no 2 there, sometimes they put the 2 there, sometimes they don't put the 2 there. This can either reduce to sine 2 theta. If the 2 is not there, it's half sine 2 theta. So basically, if I was looking at my identity, my proofs, sorry, if I was looking at my proofs, my whole aim is to get marks. I look at both sides, and as I look at both sides, I am looking to see if I can combine two fractions. If I can combine two fractions, then that's fine. And then I want to make sure that there is uniformity. If one side has got tan, change that tan to get at least 1 mark. And then from there, I'm checking to see, can I apply my identities? Can I apply my identities right there? And then from my identities, can I do my factorization? And my factorization usually is a difference of two squares. If I see cos squared minus sine squared, I know that is going to be a difference of two squares. 1 minus sine squared is the difference of two squares. 1 minus cos squared is the difference of two squares. And all these things are going to help you to do your proofs. Okay? So we are going to do some questions, and then you will understand how I'm going to work out different questions using that.